This is part 2 of our video on periodic functions. So at the end of the previous video, I asked you to try question number 4, and we're just going to quickly take up the answer. I highlighted one cycle. I always like to start at the top, so I went top down to the bottom and then back up. I said we had a maximum of 4, a minimum of -4. The period when I counted it was 12 squares, so 12. And then the amplitude, you do your maximum, take away your minimum, so 4 take away -4, which is 8, and then divided by 2 to get an amplitude of 4. So what we're going to do here is we're going to do kind of the opposite. I'm going to give you some information here, and then we're going to draw a periodic function that would match the information. So it says draw 3 cycles of a periodic function with a period of 5 and an amplitude of 8. And so I'm going to highlight all the things that are important. So the 3 cycles tells me that I need to repeat the pattern 3 times. The period of 5 tells me how long the period is supposed to be, and the amplitude of the 8 is half the height. So if I know that it has an amplitude of 8, that means that the full height is going to be 8 times 2, which is 16. So I need to draw 3 repetitions of a function that takes up 5 squares to start and finish, and then has a total height of 16 squares. So on my grid, sometimes to help me out, I make myself a little box, and then I draw my function inside the box. I find sometimes that helps me a little bit. So I know that it has to be 5, because it's got a period of 5, it's going to be 5 units long. So I'm just going to mark between that 0 and 5, my little highlighter, I just made 2 little tick marks there. And then it has to have a total height of 16. Now it doesn't have to be 8 above and 8 below, it just means all together from top to bottom it has to be 16. So I think maybe I might start at the top. And we're going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So there's 1, 2, 3, 4, 5, 6, 7, 8. 11 squares on the top, so I need 5 more on the bottom. So 12, 13, 14, 15, 16, and I'm going to make myself a little box that is 16 squares high and 5 squares wide. Okay, and inside of that I'm going to draw my periodic function. Now when I highlight a cycle, I always like to start at the top, so I tend to do that when I'm drawing these two. I tend to start at the top, and then you have to end in the same place, so you have to end at the top. So somehow in the middle here it has to make it all the way to the bottom, but what it does in the middle doesn't really matter. You could just draw yourself a big V, you could draw yourself something fancier, but you want to remember this is a pattern that you're going to need to draw 3 times, so you don't want to make it too complicated. So I'm thinking maybe I'm going to go 2 squares over, and then I'm going to drop all the way down to the bottom, and then come back up. And then I'm going to repeat that. So I'm going to do that 2 more times. So I'm going to go 2 squares over. I'm going to go all the way to the bottom in 1 square. And then in 2 squares, I'm going to come all the way back up to the top. And then I need to do that 1 more time. So 2 squares over, all the way down to the bottom, and then back up to the top. So each one of these is 5 squares long, 16 squares high, and I have 3 repeats of my pattern. Okay, so the next one is a little bit harder. This is a little bit more problem solving. The beginning parts are easy, the harder parts are a little bit more thinking. So I have a graph. It's a periodic function. So when they tell me it's a periodic function, I know that it's going to continue to repeat. So I know that after it does this, it's going to actually just keep going. So it says predict the following values, and I have f at 0. Now we've talked about function notation a little bit, but this is function notation, and this is really just asking what is y when x equals 0. It's just a little shorter way of writing it out. So what we want to do is go to our graph. We're going to find where x equals 0, which would be here, and we're going to read off that y value from the graph. So when x is 0, y is 1, 2, 3, 4, 5, 6, 7, 8, 9. So f at 0 is going to equal 9. The function when x is 0 is 9. F at 5 So that means x equals 5. So on my graph, we're going to find 5. So 1, 2, 3, 4, there's 5 right there. We're going to find where the graph is when x is 5, and I'm here at -5. So when x is 5, the function has a value of -5. So f at 5 equals -5. All right, f at 8. So I've got 5, 6, 7, 8. Right, and then we're going to read off what the value is on the graph at 8, which would be right there, and that would be -2. Okay, so 18, so there's 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So I have a problem here. This is beyond the end of my graph. So I have some options here. I could try to figure out a more clever way of figuring out what f at 18 is, or I can just continue the pattern that I see. So I think I'm going to try continuing the pattern. Since I have grids, I'm just going to continue. So I'm going to look at the pattern here. So we're going to drop down to -2, and we're going to move over 2 squares. So from here, we're going to drop down to -2, and then move over 2 squares. And then we go up 2 and over 1. So up 2 and over 1. And then we drop down 5 and over 2. So drop down 5 and over 2. And then we go up, 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 all the way back up to 9 in 1 square. And that actually takes us to 18. So what is f at 18? It's 9. 21, there's 18, 19, 20, 21 is right there. So I need to continue the pattern again. So we've already done this once. It's down to -2 and over 2 squares. And then back up 1. And then I'm actually just going to finish drawing it since I'm already in the middle of doing this. And then like this, and like that. So f at 21 is going to be 0. Okay, 50. F at 50, I am out of grid by the time I hit about 25 here. So to figure out 50, I can't just find out where it is at 25 and then double it. That doesn't really work. What I'm going to do is try to find a slightly different way of figuring this out, because I could keep drawing and get an extra piece of paper, but I don't really want to do this. Okay, one cycle of this function, if I start at the top, would be this funny looking W here. That's one cycle of my pattern. Okay, and that one cycle takes 1, 2, 3, 4, 5, 6 squares. So this has a period of 6. So whatever it is that you're going to get on the graph, it repeats itself every 6 squares, right? So to find that f at 21, I could have tried something a little bit different, and I think we'll try that first and then we'll do it here. So we want to make sure our method works. So to find f at 21, what I could have done is I could have said, okay, I've got 21. So what I want to do is figure out how many full cycles of 6 squares were there in those 21. So I could have taken 21 and divided it by 6. So 21 divided by 6 gives me 3.5, which tells me that it would have been 3 full cycles, which it was, and then we're going to be part way into the next cycle. So this is 3 full cycles, and then we're going to be half of the way into the next one. So what I'm going to do here is I'm actually going to do 6 times 3. I'm going to figure out how many squares those 6 cycles would take if I did them 3 times. So we're going to do 6 times 3, which is 18. So it takes 18 squares to do 3 full cycles. So that's going to be 18 squares. So I'm going to do 21. I'm going to take away 18, and that leaves me with 3. So I'm going to be 3 squares into the next cycle. So I know that's a little confusing. We took the number we were looking for, we divided it by the length of one cycle. So we wanted to figure out how many cycles have we already seen. And we figured out that we had seen 3 full cycles and we're now partway into the last cycle. So I figured out what is 3 full cycles. So 3 full cycles at 6 squares each would be 18. And then that means we're 3 squares into that 4th cycle. So since one cycle just repeats itself over and over again, all I have to do is look at that original cycle and figure out what 3 cycles in would be. So from here we're going to go 1, 2, 3, and that puts me at 0. Okay? So to do 50, we're going to try the same method. I'm going to say 50 and divide it by 6. So 50 divided by 6 is 8.333333, which means there are 8 full cycles and then a little bit left over. So I'm going to figure out how many squares those 8 full cycles will account for. So 8 times 6 is 48. So we're going to have 48 squares. So if I do 50 squares, take away 48 squares, which is 8 times 6, that means I am 2 squares into the next cycle. Okay, so if I'm 2 squares into the cycle, I'm going to take a look at my cycle. I'm going to go in 2 squares, and I'm at -2. So the answer here would be -2. Okay, so this is a little bit harder. You could just keep drawing, or what you do is you use your knowledge of one cycle, right? And you could actually, for these ones, just subtract. You could have done 21, take away 6, take away 6, take away 6, until you end up with a number less than 6. That would work as well. And here we could have done 50, take away 6, take away 6, take away 6. We would have done it 8 times. And then when you get a number less than 6, that'll tell you how far into the next cycle you are. Okay, so the last question here says, state 5 values of A where f of x equals -5. So this one's a little different. This isn't asking for f of -5. It wants to know where f of x equals -5. So on the graph, that tells me that my y value should be -5. So I want to find 5 points where it equals -5. So I'm going to go with the easy ones. I've got 5. This one here would be, that's 8, 9, 10. This is 11. This one here should be just before 18, so 17. And then this one here, I don't think I drew it down far enough, would be at 21, 22, 23. So that's 4 of them. So I've got 5. So at x equals 5, 11, 17, and 23. Now if I take a look at those numbers, I notice here that to get from 5 to 11, I added 6. And to get from 11 to 17, I add 6. And from 17 to 23, I add 6, because the cycle is 6 squares, right? The length of one cycle, the period, is 6 squares. So to get my 5th value here, I'm going to add on another 6. And my last one here would be 29. So all you do is we take the first value that you hit it at, and then you just keep adding 6 every time, right? Because that's the period until you have 5 values that you need. Okay, so what you need to do now is you need to take that check your understanding page and give it a try. It shouldn't take you too long. It's just answering the same types of questions that we just did about that graph there. All right.